Hey guys, welcome back to the channel, and in today's video we're going to learn about some very significant things, which is obviously about C++, as you can see in the title. um, the things we're going to learn is basically data types. It's very basic for everyone, and I hope that you really try and understand these things, because it's going to affect the whole journey that's ahead of us. And the things we're going to do here is that the data types we're going to be testing are like integer, double, strings, chars. We're going to test that, and we are going to learn the size of function to see its limitations, and in the end we're going to learn some naming rules for our variables. So without further ado, let's get on to it. Okay, so now that we are into our CodeBlocks IDE, what we have to do is we're going to check out the different data types and their limits. So we have many types of data types which we discussed in the last video. I'll leave a link in the description, also a card up here. So the first one, the most common one, is the integer data type. Then we have the double, we have the string, we have char, we have bool. These are the basic data types. So I'll explain them one by one. So integer data type, as we all know, it's basically integer numbers, and we're going to assign this variable here, which is a, and assign a value to this variable, which is 1. Then we got double, which is basically floating point. So we're going to assign a variable called b and name it 3.4. Why not? So that's that. Next we have strings. So for strings, I'm going to do the same thing. String, say we are going to assign a variable called fire equals to, not single quotes, double quotes, because strings are always double quotes. This girl is on fire, like the song. Okay, there we go. And next we have char. So we can assign, say, x. Char x equals to, now char is always defined with single quotes, and we just define it as x. So we're going to test these variables, all of them, or these data types, sorry. So cout, which is console out, and then we put in a, and let's compile and run this program. We see the value, it comes just as it is, 1. So that's integer, simple. If we go to b, which is double, b 3.4, if we run it, 3.4, simple. Now when it comes to string, we're going to see the same thing. Oh, my bad. This is what we have to type. We have to indicate this variable here. So once we run it, there we go, this girl is on fire. And the next thing is char. So char, we can do it like this, x, which also has the value. Okay, just let's change it to something like m. See what happens. There we have m. Now notice that integers have a specific size in memory, like, so we're going to check out how much size does it have. So there's this function called sizeOf in C++, and we can use this to know what size a particular data type has. So for integer, we have 4 bytes of data, like 4 bytes reserved for this data type. So anything more than 4 bytes, say for example, this is going to go way beyond 4 bytes. So look what happens. We're going to have to change this to a again, and there we go. See, a garbage value, which means it exceeds the length, the predefined length it's supposed to have, or we're supposed to put in for it. So there we go. So once again, we go to the sizeOf function and we type in double. Let's see how much the data type double has reserved for us. and it's 8. So anything more than the reserved uh, data type, like memory acquisition, will give us a garbage value. For example, something like this, and then we go crazy with this, and let's print it out. B. See, now why did all of these numbers did not print out? Because it is a double value, which is a floating point, but it only printed out the decimal part but not the rest. Why? That's because this decimal part is definitely out of scope. It's not supposed to print out this many, because it only has 8 bytes of data. And see, double or floating point always starts counting from this side. So it's like in the memory it's separated, like after decimal we have this, before decimal we have this, and it's obviously compiler dependent. So this is not ever going to come. Once we do this, there we go again. Let's do this, something like this. See, it's limited to 4 here, like after decimal only 4 digits. So it's compiler specific, but yeah, some things are predefined inside the compiler, just like this. And for some reason my alarms just went off. Wow, very sad. Okay, ignore that. So moving on to cout, then back to size of, and we have string. Let's see how much string carries. Okay, so string has 24 bytes of data. Now I have 2 computers. In my other computer it showed 8, but here it's showing 24, which means it's obviously device and compiler dependent. In your computer it might even show something else, so don't be surprised. For char, we're going to see just 1, and that's because char is a data type which stores characters like X, Y, Z, M, something like this, and it stores the ASCII value for this number or the character we're putting in. It does not store the character itself, it just stores the ASCII value, which is an integer data type. So if within 1 byte it stores just the number that's predefined, like for example for a small letter A, the ASCII value, if I'm not wrong, is 94 or 97. So it's gonna store exactly that number, and whenever we're going to wanna print it out, it's going to call that number, which number that ASCII value has assigned to that letter. Like that letter is just going to be printed out. So that out of the way, we have one more data type, which is size of bool, which I did not mention here before. So bool is boolean. Boolean only stores 0 or 1, which is obviously integer, and before even running it, I know the designed or like the predefined bytes for this is 1 byte only. So that's about it for integer or like all these data types and their limitations. Okay, so now we have learned about the data types and their limitations. We are also going to learn about a small thing, which is naming rules, because here we have using something like a, b, fire as the variable names, but there are some specific set of rules that needs to be followed when naming these. For example, if we type something like integer 3ef equals to 4, see what happens. See, there is this red box here, and it says that expected unqualified ID before numeric constant. That simply means that we cannot name a variable starting with a number. So if you move on to something like a punctuation and do the same, see, a different kind of error, but it also means the same thing, that we cannot name a variable starting with an with a punctuation like that, because and is an operator itself. So what you have to do, the first and basic rule is that when naming a variable, it has to start with a letter, no matter what, a letter. For example, first name. Okay, so let's change this thing up a little bit. We're going to use the string data type, and we're going to use something like first name, and here I'm going to give underscore. You'll know why. Name equals to, say, John Doe. That's the basic name for any unknown person, but it's okay. We're going to run this. Oh, sorry, this thing needs to be changed. So here we're using first name, last name, and when we print this, we will have John Doe right here. Notice if I change this to something like this, okay, now you can ask me that I said that you cannot use punctuation in the beginning. What about in the middle? Well, check this out. See, error, because no matter where I use this and or star or plus, this will always mean that it's an operator, because it's a predefined operator. It has a different meaning, and if I use it anywhere in the scope, no matter where, the compiler will not know if it's a variable or not. So we have to follow the rules for naming a variable. Okay, so once we remove that and run, there we go. It's fine, it's running perfectly fine. So another thing we can do is like, okay, fine, so we cannot use a number in the beginning. What about at the end? Let's try it out. We do this and it's fine. You can do that. No issues whatsoever. Even at the beginning, let's put a punctuation in the beginning. For example, something like this. Underscore. Compile and run, and it's going to run because this is allowed. Some punctuations are allowed, okay, so you can use them, but not again something like this. Like, okay, I think this is also allowed. I haven't tried this one, but no, this is not allowed because it has a different meaning. So even this, no, if this means not, we will know it in a separate video, but we can't use something like this. So the basic thing is, the first and foremost rule, always start with a letter. That's the basic thing. Number two, well, of course, always start with the letter, and never start with a number slash punctuation, except the underscore. Okay, so that's basically it. And also there are some unofficial or maybe official, like rules for novelty, something like you should not have variables this long, like first name and last name, or something like the day I visited your grandmother's grave or something like that. You should never use that, because it ruins the program in a way, because if someone else reads your program back then, that person will get disgusted by your programming. Program is not just about making it work, it's also about decoration. It's also about some nice behavior, some politeness, some aesthetics to it. So in order to follow that, you should always follow these naming rules. And that's about it for this video. I hope you enjoyed these small details, and we'll hope to see you again in the next episode. Till then,